Hello, so this is the second video of the quadratic equation or the quadratic function. And in this case, I want to go over um, other cases. Oh, I'm sorry, it's okay. No, it's fine. Um, let's take an easy function, another one. So suppose I have an equation that says uh, x squared plus 12x plus 36 equals 0. And I want to factor that. Notice, in the previous example, we had the c was negative, right? So we wanted two numbers. Well, it really doesn't matter, but because it was negative, we were looking at the difference of 2 points. If I'm going to remind you of what we had before. That was the first example we did. So we say because that's a negative, remember we said we need two numbers that their product is the absolute value of AC and the difference is the absolute value of B. But here, because this is a plus, we are going to say we are looking for two numbers, the product of which is the absolute value of AC. In this case, it doesn't matter because AC is positive. So their product is 36. And there's sum, not difference. Why sum? Because that was a positive. Their sum is the absolute value of B, which is 12. Notice that I have multiple cases. I can say 1 and 36, well, they add up to 37. 2 and 18, they add up to 20. Still too low. As you get them closer, the product gets higher. So 3 and 12, now I reach 15. 4 and 9, that's 13. 6 and 6, sorry, you get smaller. I started with 36. Yeah, you get smaller until you get 6 and 6. 6 times 6 is 36, and 6 plus 6 is 12. That's easy. So basically, it's x plus 6 quantity square, or you can write it as x plus 6 times x plus 6 equals 0. Oh, that's why we have two answers, but the two answers coincide. We have a unique solution. We have the case where if that's my parabola, it's doing this. First of all, it's opening up because this number is positive, and I get x equals, or x plus 6 equals 0. I'm going to subtract 6 from both sides. And I get x equals minus -6 and x equals -6. I get twice the same value, so it's just one answer. Something that would help you later in graphing is that because x plus 6 happens twice, if you get a root that occurs exactly, not exactly twice, but if it's repeated an even number of times, we call the number of times a root appears or a factor appears, its multiplicity. So in the previous example, when we had x minus 5 times x plus 2, each factor appears once. So the multiplicity was 1 for each. But here I have x plus 6 and another x plus 6. So the multiplicity is 2. If the multiplicity is even, the graph never crosses the x-axis at that point. It either goes down, touches and go up, or goes up, touches and come down. And that's what we have here, a multiplicity of 2. Okay, that's not really an important thing, but it's good to know for now. Later you will learn it from a different perspective, when you do graphing of functions. Now, notice that if I wanted to complete the square, it's already a perfect square. What did we do before? We said take the middle point, divide it by 2, it will 6, and then square it is 36. But it's already 36, so I don't need to add or subtract anything. right? And the -6 is the axis of symmetry. It's the x-coordinate of the parabola. Very easy. It's the problem is solved. If there is no need to, so the completing the square doesn't make any sense here because you're already a complete square. If you want to use the function or the quadratic equation and you substitute -b plus or minus whatever, the quantity b squared minus 4ac would be 0 because b squared is 12 squared 144 minus 4 times 1 times 36 minus 144. So that was a very simple example, but it illustrates the perfect square or when you get a unique solution. Okay, now let's take another example that maybe, let's make up an example that is tough. So I'm going to say 3x squared plus 8x, whatever. I need any number that doesn't work nicely, so to speak. So I'm going to say plus 2. That's f of x. And I want to solve that. If I try to factor, I'm looking for two numbers whose product is 6 and their sum, because that's positive, is 8. Notice that the biggest product you can get, remember we said, as you go, and you will learn that also in statistics later in your career if you take courses there, that if you have two numbers that add up to 10, the largest possible value that you can get is if you use a very like if you say 1 and 10, if you are using only discrete integer values, okay? 1 and 10, they add up to 11. 2 and 5, they only add up to 7, and there is nothing else. But if they were, meaning if you take the square root of 10 and the square root of 10, that's the least sum that you can get. So here the biggest number I can get with 3 and 2, which multiply to 6, is 1 and 6. But 1 plus 6 is 7. That's the maximum you can get. And this is 8. So no matter how hard you try, there is no way you can factor that. Right? And because you cannot factor it, you are left with two possible scenarios. One of them is really tough, which is completing the square. But I'm going to show you because I want to illustrate another point. So we'll kill two birds with one stone, as they say. I'm going to come here and say, to complete the square, remember we said, put the x squared and the x coefficient together and leave the third one out. Usually it's easier if you simplify, you make the x squared coefficient 1. Don't leave it as 3. Some people will tell you make it a perfect square by multiplying the whole equation by 3. You can do that, but it's simpler if I factor out the 3, and that leaves me with x squared plus 8/3 x plus 2. Remember what we said in order to complete the square. Notice that this will always be plus something. And what is this something? I take b over 2 and then square it. B over 2 in this case is 8 divided by 2 times 3, meaning 4/3. Right? If you divide 8 by 2, you get 4. So 8/3 will become 4/3. And then you square it. When you square it, the 4 squared is 16. The 3 squared is 9. And here comes the error that many students do. They say, oh, I added 16/9, so let me subtract 16/9. Did you really add up 16/9? No. Every time you factor something out, it means you have to be very careful. Even if that was a negative, suppose this was -3. and I factored out -3, I would have said I didn't add 16/9. In fact, I subtracted 48/9. So I have to add 48/9. Do you see what I'm saying? If you factor out anything, you have to be very careful. I didn't add 16/9 because if I add 16/9 here, it's not a perfect square. I had to add 3 times 16/9. So I have to subtract 3 times 16/9. And now my equation is correct. I know it's tough. You have to be very careful. Notice that if I if I distribute the 3, I get 3 times x squared is this guy. 3 times 8/3x is that guy. And 3 times 16 is 48/9. So I have to subtract 48/9. Extremely important to notice. If you factor something else out, you have, before you subtract or add, multiply it and see what you usually, or what did you really added or subtracted, and do the opposite outside. Now, we know that this guy is x plus 4/3 squared. You don't need to check that. We know that. And then here I say plus, the 2 is 18. 2/9, so 2 is 18/9 minus 48 equals 0. So I'm going to say 3 times x plus 4/3 square minus, because 18 minus 48 is negative, 30/9 equals 0. I can move this to the other side, or I can simplify. It doesn't matter which one you do first. So I get 3 times x plus 4/3 square equals 30/9. I see that 30/9 can be simplified as 10/3. And then I can divide both sides by 3 again, right? So divide this by 3 and divide this by 3. Those two would cancel, and I get x plus 4/3 square equals 10/9. I take the square root of both sides, left-hand side, x plus 4/3. What is the right-hand side? Don't forget, plus or minus the square root of 10/9, which is plus or minus the square root of 10/3. Now, finally, I'm going to subtract 4/3 from both sides, and I get x equals -4 plus or minus the square root of 10/3. Notice I just used the common factor, and usually I wrote the -4 first, and then the plus or minus root. So that's an irrational number. It doesn't matter. Doesn't matter. Both of them are in the negative side, but I get either x equals -4 plus root 10/3, or -4 minus root 10/3, and these are the answers. Notice that if I try to take the average of the two to find the axis of symmetry, if I add these two numbers and then divide them by 2, notice adding the numbers will get the root canceling each other. So I get -8/3. And then I'm going to divide them by 2 to get the average. So I get -4/3. Right? Because you have -4/3 and -4/3, then their average is also -4/3. Notice that -4/3 is -b over twice a, which you learned, so to speak, when from a different point of view. Finally, I'm going to use this and answer or solve this problem using the equation. So we have 3x squared plus 8x plus 2 equals 0, right? Yeah. And I said A is 3, B is 8, C is 2. So I say x equals negative b, negative 8, plus or minus the square root of b squared, 64, minus 4 times 3 times 2, over twice a, equals negative 8 plus or minus the square root of 64 minus 24, right? 4 times 3 is 12 times 2 over 6 equals negative 8 plus or minus the square root of 40 over 6. But 40 equals 4 times 10. So you could have written this as negative 8 plus or minus the square root of 4 times the square root of 10 over 6. We know the square root of 4 is 2. So equals negative 8 plus or minus 2 root 10 over 6. You can simplify by 2, by 2, by 2. And sure enough, like before, you get negative 4 plus or minus root 10 over 3. Negative 4 plus or minus root 10 over 3. Okay? So that's usually the second scenario, which will yield, like when we use it, you will get you cannot use factoring because the answer turns out to be irrational. And later in the third video, we'll see if the answer is imaginary, you also wouldn't be able to use uh, the factoring method. Even though I want to, at the time, I may show you something that hopefully will be helpful to you. I don't know if we take another example or that illustrates the point. I think we did what happens if the C is positive or AC is positive versus AC is negative. When it's negative, you look at the difference of 2 points. When it's positive, you look at the sum of 2 points. And if you are looking at the difference of 2 points, you look at the sign of B to know which one is the bigger. Is the bigger positive or negative? Okay, like we saw previously. We knew that the negative is the bigger one. So we said x minus 5 times x plus 2. If that was a positive, I would say x plus 5 times x minus 2. We'll take another example where it's not easy to see, like something similar to that, probably next time. And then we'll go over what happens if the answer is imaginary and how we know that. In fact, I can tell you from now, what you should do is to look at the discriminant to begin with, meaning look at the quantity between the radical and see whether it gives you a positive, a 0, or a negative before doing anything. So if it gives you a positive number that is a perfect square, then you can use factoring. If it doesn't give you that and it's positive, it means the answer is rational. So probably you use this equation or completing the square, which usually, unless you are forced or asked to do it, it's not the easiest method. This method is easier. Okay, and if it's negative, then definitely you are not going to use factoring. So factoring only if the quantity under the radical is a perfect square. It's 1 or 4 or 9, 100, 64, whatever. Okay, so in this case, by the way, when we said, so finally we're going to say we had x squared plus 12x plus 36. So we do A is 1, B is 12, 36. C is 36. I say, what is B squared minus 4AC? I'm going to use my calculator and say B squared minus 4 times 1 times 36. I get 144 minus 144 equals 0. Because it's 0, I know I have the distinct answer. And I can use the factoring method. When I had this equation also, x squared minus 3x minus 10. I say A is 1, B is negative 3, C is negative 10, and B squared minus 4AC equal B is negative 3 minus 4 times A times C equals 9. Negative times negative is positive, and 4 times 10 is 40. So I get 49. I know that 49 is 7 squared, so I can use the factoring method. So that's a quick check you can do in the beginning to know which method you use. Okay, can I factor it, or it's not factorable, so to speak, from the point of view of simple algebra? Okay, I hope that was helpful, and I'll see you next time. Bye.